Hello everyone. So in this example we're going to look at the mean, median, and mode for problems. We're going to look at 3 different data sets that are either like skewed, symmetric, or skewed another way, and kind of discuss the mean, median, and mode for each of the following problems. So let's look at the first graph. Alright, so the first graph, this is a dot plot. Okay, so it's kind of like a histogram. You're recording 2010 Winter Olympics gold medal won by the 20 medal winning countries. So you can see that this data here is skewed. And most of the countries are like winning 0, 1, 2, 3 gold medals. There are some that are winning much more, 9 and 10, and one that wins 14. So this is skewed right. So when most of the data is concentrated on the lower end and you have a few outliers on the right end, this is skewed right. Okay, so when the data is skewed right, you have like some outliers, one or few large values compared to the rest of the data, then the mean is pulled to the right. It's bigger than it would be if that outlier wasn't there. So the mean is pulled to the right. Now the median doesn't change much if you remove that outlier, so the median is like somewhere in the middle of the data, but the mean becomes bigger because that bigger data value pulls it to the right. Okay, so this is like the mean and the median. Now you can calculate the mean and the median if you kind of just want to input all these data values into StatCrunch. And I did that. The median was around 3, and the median was, that's the median, and the mean was around 4.25. Right? So this is like a property of asymmetric graphs that are skewed to the right, that the mean is larger than the median. Alright, now the mode of this is 1, because that's the most data values. The mode is a little different. It often doesn't really have a relationship with sort of the mean and the median. It's just sort of where the most values are. For a graph that's skewed to the right, the mode tends to be on the right side because that's where most of the values are. Alright, so let's look at the second graph. So the second graph, it's a stem and leaf plot. If you kind of look at it as a little histogram on its side, so if you look at this graphical representation here, this looks pretty symmetric. Alright, it's not perfectly symmetric, but in a symmetric graph, the mean and the median and the mode are approximately equal to each other. You can see sort of the mode is where the biggest bar is, around 60 something, and if you calculate the mean happens to be at 70.4 and the median is at 69. So it's like they're very, very close to each other. All right, so these are approximately the same. And the mode in a histogram, it's not necessarily the value that appears the most, is basically where the highest bar is. So the highest bar is around the 60s. Yeah? Right, the last graph, hours spent playing video games on weekends. We're given a histogram here. You can see this is definitely asymmetric, and this is skewed to the left. Skewed left. Alright, so in a graph that's skewed left, most of the data is on the right, and a few of the data is on the left. Okay, so you might have outliers here. Okay, you can see like a couple of people are playing between 0 and 5 hours. Most people are playing loads. Okay, so skewed left, the mean is pulled to the left. All right, so you have those smaller values, couple of smaller values is going to lower the mean. Okay, so in these kinds of graph, the mean is less than the median. All right, so if we look at this graph right here, if you basically put this data in StatCrunch and you calculate it, you don't have to, but just to kind of confirm what we're saying here, the mean is around 16.1. So this is the mean, around 16.1, and the median is around 17.5. Right, and this is the mode right here. Right, and it's hard to identify a particular mode because it's all lumped together. Okay, so the important thing with graphs are they're skewed to the left. The mean is less than the median. All right, that's it.